Algebra 1, Chapter 7.4, exercises 1 through 16. Find each sum or difference. We're going to be adding and subtracting polynomial expressions. Here you have number 1. I'm going to do in this video lesson the odd-numbered problems in this set. We have the expression quantity 4p squared plus 5p plus quantity negative 2p squared plus p. And what I'm going to do is rewrite this expression, removing the parentheses. So we have 4p squared plus 5p. And now we have this plus, so the plus distributes to each term inside this second binomial. So this one here is minus 2p squared and then plus p. So we have these four terms now, and we have p squareds and p's. So we take this 4p squared and this minus 2p squared, and combining them, 4p squared minus 2p squared is going to be 2p squared. And then we have this 5p plus p, which adds up to plus 6p. And so this is going to be our correct answer, 2p squared plus 6p. And sometimes I like to, as I go ahead and combine these like terms, to kind of check these as we go off, but we're going to examine that in future ones. Let's go to our next odd number problem. 3, we have quantity 8cd minus 3d plus 4c plus quantity negative 6 plus 2cd. So rewriting without parentheses, we have 8cd minus, and what I'm going to do is kind of rearrange these in a little bit of order. Now I'm going to go ahead and just rewrite it. 3d plus 4c, and now we're going to distribute again the plus sign, so that plus negative 6 becomes minus 6, and then we have plus 2cd. And so in this expression now we have 5 terms, and we look for the like terms. We have CDs. I see we have 8 CDs here plus 2 CDs here, so that's going to be 10 CDs. And then we're going to have this plus 4C, then we have this minus 3D, and finally minus 6. So that's going to be our answer for problem number 3. Next odd number problem, 5. We have quantity 6a squared plus 7a minus 5 minus negative 5a squared plus a minus 10. So we're going to rewrite this one now. In this case, we have a negative sign in between these two expressions. So that's going to make a significant difference here in how we do this problem. So we have 6a squared plus 7a minus 9. And now we're going to distribute this negative sign here to each term inside this trinomial. So we have minus negative 5a squared, which becomes plus 5a squared. And we have minus a and minus negative 10, which is plus 10. So if you look at this second trinomial here in parentheses, what this negative sign does is it switches the signs of everything inside this trinomial right here. Okay, so that's one way to look at it. So combining like terms, we have 6a squared plus 5a squared, which make 11a squared. And then we have 7a minus a, and see I'm checking these as I go to make sure we're accounting for everything here. So 7a minus a is going to be plus 6a. And finally we have negative 9 plus 10, which is going to simplify to be plus 1. So there we have our answer for problem number 5. Next on our problem 7, we have quantity 3ax squared minus 5x minus 3a minus quantity 6a minus 8a squared x plus 4x. So rewriting this expression, we have 3ax squared minus 5x minus 3a, and we're going to distribute again this negative sign here. So we have minus 6a, we have minus negative 8a squared x, so that's going to be plus 8a squared x, and finally we have minus 4x. Now in this one we're going to have to be a little bit careful in how we do things. We're going to go in order of powers of x. So we're going to take this 3ax squared. Now one thing you got to be careful about here is that almost looks the same as this one here, 8a squared x, but it's not. It's not, because they're different. You have one is x squared and one is x. So we check that off. Next, let's come over here to the a squared x. So plus 8a squared x. And the next one we're going to look for is the x term. X terms, we see we have negative 5x minus 4x, which simplifies to become negative 9x or minus 9x. Then we have negative 3a minus 6a is going to be minus 9a, and that takes care of those. And I think we've checked off every single term, so this is going to be our answer for problem number 7. Okay, next on our problem, a population for exercises 9 and 10 use the following information from 1980 through 2003. The female population F and the male population M in the United States in thousands are modeled by the following equations, where N is the number of years since 1980. And we have an equation here for F and for M. And it says 9, find an equation that models the total population T of the United States for this time period. Well, what we have is that our total population is going to be equal to our female population plus our male population. And now replacing, we have F equals, I'm going to put 1,000. In fact, I'm going to do it without the comma there. T equals 1,379N plus 115,513, and then we have plus the male population, which is 1,450N plus 108,882. And so we're just going to add those together. So our total population is going to be equal to, we're going to take this 1,379N and add that to 1,450N, and for that we get 9, 12, 8, 2. So that's going to be 2,829 T. We got that wrong. 2,829 N. There we go. And then we're going to have this second set the number itself, so 115,513 plus 108,882, and adding these together we get 5, 9, 13, this will be 14, and 2, 2. So we had plus 224,395. So that's going to be our total population. And then, well, I'm not going to do this one. Problem 10 is if this trend continues, what will population of the U.S. be in 2010? Well, 2010 is going to be 30 years away from 1980. So if we go ahead and take this expression and plug in 30 for n, we should be able to get our answer for problem 10. Next on to problem 11. Find each sum or difference. Again, we have 26n squared minus 4, so I'm going to rewrite this as 6n squared minus 4, and then we distribute in the second set here the plus sign, so we get minus 2n squared, and it's going to be plus 9. And now combining like terms, we get 6n squared minus 2n squared, which is going to be 4n squared. And we have negative 4 plus 9, which is going to be plus 5. And there we have it. Problem 11. Next on our problem, which is 13, we have 23 plus a squared plus 2a. And I'm going to write this here, this first 3 terms within parentheses, as a squared plus 2a plus 3. Now, why did I rewrite this in a different order? Well, I want to get closer to eventually what we're looking for, which is standard form, which is the exponents in order from greatest to least. And the next one we have here is distributing the plus sign. We have plus a squared minus 8a plus 5. And now combining the like terms, we get a squared plus a squared, which is 2a squared. We get 2a minus 8a, which is minus 6a. And then just check these off as we go. And finally, 3 plus 5 is going to be plus 8. Now, I have a lot of students who will just mentally work this out from this top line, go directly to the answer, and that'll work a lot of the time, but you got to be careful here, because sometimes it's this intermediate step that will help you organize things better to improve your odds of getting the right answer at the end. The last odd number problem in this set is this one right here. We have quantity x plus 5, so I'm put here x plus 5, plus, and we're going to have, again, distributing the plus sign, I'm going to put plus 4x plus 2y minus 2. And again, I changed the order to just for organizational purposes to make it a little easier for me. So we have x plus 4x is going to be 5x, and then we have just one single term with y, so we have plus 2y, and then finally we have 5 minus 2, which is going to be plus 3. So that's going to be our answer for problem 15. And I'm not going to do this problem, but here's problem 16, so it should be pretty easy to do. So that's all I have in this video lesson. I hope this has been helpful for you today. Good luck, and thanks for viewing.